is a logarithmic equation that we need to solve. And it has a lot of different aspects to it. So I'm going to start, since I have this, if it's just log, we know that it's log base 10. So all of these are log base 10. And I know that if log A is equal to log B, then A is going to equal B. So I'm going to see if I can't get this into a form where I can use that property. Well, I'm going to start by condensing this logarithm right here, because I know that log A minus log B is the same thing as log A divided by B. So this would be log x plus 4 over x. And that is equal to log x plus 2. Well, that has just pretty much solved my problem, because I can now use this property. Just remember, what this is telling me over here, this is telling me that a logarithm is an exponent. And this is telling me that whatever the exponent is on 10 that will give me the answer A, it's the same exponent on 10 that's going to give me the answer B. So A and B have to be equal. So now I have this is going to be equal to that. So I have x plus 4 over x is equal to x plus 2. Now, you have to be very clear here. When moving from this to that, you do not want to write log x plus 4 divided by log x. That is incorrect. You will get points off for that. That is not, this is proper. This is not proper right here. This is not proper. You cannot then cancel out the logs. Canceling out a log is like canceling out a plus sign or something. I mean, if I had 5 plus 3 over 2 plus 1, canceling out a log would be like canceling out the plus signs, which doesn't make any sense. Logarithm is an operation that we're performing, and you can't just cancel it out. So make sure you understand your properties of logs and you write it correctly. So I did get down here to x plus 4 over x is equal to x plus 2. So I'm going to multiply both sides by x. That x is going to go away. I'm going to have x plus 4 is equal to x squared plus 2x. Well, I have a quadratic here, and I want to solve a quadratic. So I'm going to get everything on one side. Since my x squared is on my right, I'm going to go x squared. And then this is going to be, I'll subtract x from both sides. So it'll be plus x minus 4 is equal to 0. So x squared plus x minus 4 is equal to 0. And I know there's no factors of 4 that I can use that will get me 1. So I'm going to have to use a quadratic formula to solve this. I'm going to start with the discriminant, which is b squared minus 4ac, because I want to make sure that there's actually a real number solution to this. So b is 1 squared minus 4 times a, which is 1, times c, which is negative 4. So this is 1 plus 16 equals 17. So that's what's going to be underneath my radical sign when I use the quadratic formula. So my quadratic formula is negative b plus or minus square root of b squared minus 4ac over 2a. So I have negative 1 plus or minus radical 17, because I already calculated my discriminant right here, divided by 2 times 1, not 11, 1. And that equals, well, it equals just that, negative 1 plus or minus radical 17 over 2. Those would be my values of x. The only thing I need to do is make sure that this is not a negative number. Because if that is a negative number, I have to go back to my original equation. I cannot have a negative argument of a logarithm. So if it's a negative number that's bigger than 4, that would be negative. But right here, if it's a negative number at all, that would make that x negative, and that would mean that would be an extraneous solution. So the way I check to make sure it's not a negative number is I pull out my calculator. And I say, well, the smallest number would be minus 17. So I'm going to go minus radical 17. So I'm going to go negative 1 minus square root of 17. What's that equal? Uh-oh. I'm going to divide it by 2. I have a negative number. So the only solution then to this problem is 1 plus radical 17 divided by 2. That is the solution to this problem. I cannot have x equal to a negative number, otherwise it will violate my the domain of my logarithmic expression here.